Welcome to CANA Mimic Technologies, Adaptive RF-enabled manufacturing. At CANA, we empower federal and commercial organizations to thrive in a global digital world through precise and adaptable technology solutions. We fuse our rigorous analytics, top-tier talent, and specialized expertise to design customer-centric, powerful solutions. We strive to create an environment that allows our team and clients more time to focus on the things that matter most. Modern unmanned systems are being pushed into electromagnetic environments they were not built to survive. CANA's Mimic family of technologies turns the structure of a platform itself into a functional RF system, a chassis, wing, skin, pod, or wearable surface that can protect, sense, harvest energy, or shape RF interaction based on the mission need. The reason unmanned systems matter now is not just that they are new, they are becoming operationally required. They provide mass, reach, persistence, and distribution at a price point that manned or exquisite systems cannot match. But the same platforms that make this force design possible are often fragile in contested RF environments. That is the gap Mimic is built to close. Today, protection, sensing, antennas, and other RF effects are usually added onto the system. That can work for a single platform, but it does not scale well across mixed fleets of commercial and military unmanned systems. It also creates a size, weight, power, cost, and logistics penalty. The operational problem is that forward units need unmanned systems, but they also need those systems to adapt quickly as the RF threat changes. Mimic changes the process. When intelligence indicates a need for a specific unmanned capability, available platforms can be scanned, assessed, and matched against a library of Mimic-enabled component options. Those components can then be manufactured and integrated close to the point of need. The value is a repeatable cycle: observe, assess, manufacture, and deploy. The technical advancement is the move from bolt-on protection to built-in spectral engineering. It's vital to note that while software adapts signals, it cannot stop physical HPM damage, alter structural RCS, or operate at zero power. Mimic provides the physical layer software can't replace. Mimic treats the airframe, chassis, pod, or wearable material as part of the electromagnetic system. This enables a family of effects: Mimic for hardening, Radar for sensing, Reaper for RF energy harvesting, and Stalker for the soldier wearable edge. Operationally, the concept is an RF overmatch adaptation cycle. Forward forces encounter a new RF environment. Radar-equipped UXS and Stalker-equipped personnel collect data. That data is relayed to a Mimic hub, where the information is analyzed and matched to a hardware response. Adapted components and systems are then manufactured, integrated, and pushed back to the forward edge. Developed over a decade at GTRI's Athena lab, Huygens unit cells, meta-atoms, form the digital smart skin behind Mimic. These subwavelength structures manipulate EM wavefronts with high efficiency and offer wideband impedance control across L through K bands, 1 to 40 GHz. Using compact multi-material 4D printers, functional RF responses are embedded directly into structures, delivering complexity at no cost for marginal polymer expense. The smart skin routes surface EM energy away from sensitive payloads and enables passive spoofing via Van Atta reflector rays. By integrating metamaterial intelligence into additive manufacturing, Mimic delivers zero-power RF resilience. CANA brings the operational, analytic, and integration experience needed to move this from a laboratory concept to useful defense capability. The team combines unmanned systems employment, logistics analysis, electrical engineering, EW validation, and world-class printed RF expertise. That combination matters because the transition problem is not only whether the physics works in a lab, it is whether the capability can be integrated onto real platforms and tested against operationally relevant mission threats. Mimic gives the department a way to move from buying fixed unmanned platforms to generating adaptive RF-enabled capability at the edge. The DARPA-relevant transition work is straightforward: prototype integration, RF testing in dynamic environments, airframe benchmarking, and mission thread demonstrations that connect observation to component selection and fielded adaptation. CANA is seeking ERIS engagement to mature and transition this family of technologies into operationally relevant defense applications. CANA's Mimic family of technologies offers a path to technological overmatch by encoding survivability into platform geometry, eliminating the traditional logistics tail. Through our digital library of defense, any scenario can have a printed response on site. Partnering with Mimic means adopting a manufacturing paradigm that makes platforms more resilient in contested environments while optimizing SWaP-C. With the GTRI Athena lab and our leadership team, we have the vision and manufacturing pipeline to deliver this today. We are the CANA Mimic family of technologies. Thank you. For more information on CANA's Mimic family of technologies, please contact CANA's Director of Innovation and Strategy, Chris Sitchi, or visit canallc.com.